Welcome to Channel 4, this time on Zoom. And I love how we're sort of zooming around from one platform to another to support this conference. Really excited about our next conversation, which is going to be about 5G networks. I personally have a bit of a background in networking, as many Canadian technologists do. And I was at a conference many years ago and met a fellow named Jim Gray, who just was an amazing researcher at Microsoft. But what he said really stuck with me is that asked about the future of computing, he said, compared to the cost of moving bits, everything else is free. And that really stuck with me. And at the time, I really kind of rejected it. And then over the years, I found myself feeling every year it's truer and truer, which is why I'm so excited to welcome to the conversation today to present to us on 5G and why it's more than just about speed. And I'm on the edge of my seat here to welcome Stephen Howe, who is the Chief Technology Officer at Bell Canada, has a long career in telecommunications himself, and happens to also be have figured out his own solution to the pandemic, is doing a lot of running, is what I understand. Welcome, Stephen.
Great, thanks, Ian. Appreciate it. And welcome, bienvenue à tous. Thank you for joining the session today. I'm going to share my screen if you give me a moment.
As Stephen's getting set up, I just want to remind folks to please feel free to add questions in the chat, and those questions will be there'll be an opportunity for Stephen to address those questions at the end. And I also want to remind you that this will still follow the terms and conditions we all agreed to participate in the conference. And with that, I hand it back to Stephen, who's looks ready to go.
Great, and Ian, everyone can see my screen now?
It looks perfect.
Perfect. Okay, a couple things before I start. A little bit about my background. As far as the agenda goes, I'll talk about my background just a little bit for the international people in the audience, a bit about Bell, so that people get some context to this 5G journey that we are on. And then then I'll go into 5G. I actually have 4 sort of distinct chapters, if you will, on 5G. And I'll be sure to pause at the end of each chapter if I can reflect on some questions from that chapter. That would be great. But I'm happy to take questions throughout. I won't be actively monitoring the chat room. So Ian, if you can just bump in and tell me to look at the chat for the question, or you can read the question out, that would be great as well. So I do have to apologize in advance. I do tend to use a lot of acronyms. So if I lose someone, please also just raise your hand or send the chat room and I'll clarify something. So, you know, technology does shape every facet of modern life. I took this from the website, but will it hurt us or help us? And that's a big question. And I always believe as a technologist and really a technology person through and through that it'll absolutely help us in the long run. And 5G in particular is one of the key enablers for our collective society and the new digital economy going forward. So this presentation is more technology centric, bit of a primer, if you will. And with that, let's get right into it. You'll see over my shoulder here, this is a legitimate, it's called a picture frame wall phone. It's from about the 1920s. And the reason why I show this is part of an introduction to me. No, I'm not 100 years old, obviously, but I've been in telecom really since I was a kid. This phone was at my grandmother's farm up in Richmond Hill, the corner of Bayview and Major Mackenzie. The farmhouse is still there, although surrounded by malls and such, but the farmhouse is still there. And I grew up sort of playing with this phone, if you will, on what's called a party line. For those that don't know what a party line is, you can Google that and be fascinated that people used to be able to listen in on your conversations. That was in Richmond Hill, Ontario, just north here of Toronto. I was born and raised in Trenton, Ontario. My dad was a teacher, my mom was a mom, and they really instilled in me a love of science, engineering, and math. And from there, I went to McMaster University in Hamilton, Ontario. Engineering physics was my major, which involved a lot of math. From there, I went actually south of the border to Ithaca, New York, which is home to Cornell University, and took my master's there. And so I'm one of those rare people, because from there I went to a lovely place called Corona del Mar in Southern California, Crown of the Sea, and did a lot of work with early wireless startups, Qualcomm being one of them. This was very early days, mid-90s of Qualcomm, and early days of Verizon and so on. And so spent a lot of time in the US working with various wireless technologies. And that then took me back across the border in the late 90s to Pickering, Ontario. So I'm one of those rare people who left the US, and I'm very pleased, not just because of the last 24, 48 hours, but very pleased to be back in Canada the last 20 or so years, because it really is truly my home. I'm a very proud Canadian, and helped start up a company called ClearNet that became TELUS, that many Canadians may or may not know. And my last stop, really for the last 13 years, has been with Bell Canada, based out of Toronto. That's just a little bit about my background for those that are interested in why I feel qualified at least to talk about 5G. Bell Canada has been connecting Canadians since 1880. We are arguably the oldest telco in the world. Really the founding from the early patents from Alexander Graham Bell himself, and who was Scottish Canadian. And not a lot of people know that, because the US would quote unquote have adopted him and would claim to have a lot of his inventions, but in fact he invented did most of his early work here in Canada. And we've been around for 140 years, which is pretty incredible. You can see at the bottom of the slide, and I'm not going to spend a lot of time on Bell, just a little introduction like I mentioned for the international audience. One in every 350 employed Canadians actually works at Bell, so a really large company. 22 million customer connections. That's in a population of 34 million, so pretty big numbers, and traded in the stock exchange and everything else that nature. If you do have questions as it relates to our financials, I won't be able to answer them because our financials get released tomorrow, so I'll stave off any of those types of questions should you have any. As far as our revenue mix today, we 100% 140 years ago would have been all in the, of course, business and home phone. And we've really transformed the company in the last 10 years or so to be a real broadband leader. And you can see that internet, broadband TV and internet is about 37%, wireless 36%, and a smaller component on the media side through TSN and CTV and so on. And my last Bell slide is really all about the network. We do believe in delivering the best network for Canadians, and we could really see this as part of the, during the early days of the pandemic, whether video conferencing was up several hundred percentage points week over week. Internet usage was up massively. Wireless usage was up massively in those first early weeks. And so, you know, delivering the best network is a key pillar of our marketing campaigns. For those in Canada would see that in our marketing campaigns. It's all about delivering our Bell Canada goal, which is at the very bottom here, advancing how Canadians connect with each other and the world. And nothing could be more important than connection during these turbulent times. And then you see a few of the brands that we support. These are all internal Bell brands, whether it's the Bell brand itself or Bell Alliant out east, Bell MTS in Manitoba, Bell Media, and the various TV and other properties that we run, radio as well. So with that, I'll get into 5G. And one of the first questions I often get among friends and family is, okay, why call it 5G and what does G stand for? G, simply put, is for generation. Excuse me, jumped ahead there accidentally. And that's really all it stands for. First generation of wireless was analog only. It was really invented in the early 70s and really came into commercial existence in sort of 85, 86 timeframe, and it was voice only. The second generation was the first time it became digital. And that was in the early 90s, and there were two digital technologies at the time, GSM, which was really more founded out of Europe, and CDMA, that was more founded out of the US and became more of a North American ecosystem. And so those two ecosystems kind of survived until one ecosystem eventually took over and became the third generation, HSPA, high-speed packet access. And it really started this world of data that we know about. Fairly slow speeds, 42 megabits per second. You can see that, and that was in the early 2000s. And then 4G, something called long-term evolution, came along, and it's when really data took off. It was full IP packet end-to-end. It allowed for HD streaming and a lot of high-speed internet. In fact, this is what Bell offers today with speeds up to 1.5 gigabits per second to 99% of the population. We also have a very large rural wireless broadband service that we offer to rural Canadians, particularly important nowadays to nearly 500,000 homes in our footprint. So this is the technology we are using today as our mainstay, if you will. And last but certainly not least, in the major portion of this presentation will be about 5G. We've been working on 5G within Bell for about 2.5 years, early lab trials, you know, ensuring that we were following the vendor ecosystems and things like that. And ultimately, it'll have speeds north of 10 megabits per second. I'll talk a little bit about that journey. There'll be IoT, private networks, all that cool stuff that you read about. But we are a ways away from that, which is why on this slide I say 2020 plus for that technology. And you'll see how with the 4 pillars I'll talk to how that unfolds. Now, Gartner, and many of you have probably seen this, but Gartner has what they call the hype cycle. And so I've borrowed that for this presentation. And you can see this is really just a directional view. You know, some of these really innovative things that you read about, whether it's flying autonomous vehicles or delivery drones, those are a ways off. And eventually they hit a really peak of inflated expectations. And so you can see the flying autonomous drones, autonomous cars, and so on, really at the height of the expectations. 3D sensing cameras, okay, you know, they didn't really make it into the market. They're heading towards what's called the trough of disillusionment, which I find is a fascinating word. But out of that trough of disillusionment, and virtual reality was there as well, came out, and something called the Slope of Enlightenment, which is, okay, people are really starting to get it. They understand what it means, they understand how it works, and eventually it becomes much more mainstream. And almost every single technology goes through this, not just 5G, which I'll get to in a moment, but whether it's going from records to 8-track tapes to cassettes to CDs and now to streaming, all have followed a very similar curve to this. And if you think back the way you may have interacted with music over the years, you can see how that curve, you get really, really excited about a new technology and, oh, it didn't quite live up to it, but oh, you know, it's actually good enough. And that's something. And 5G is following that exact same curve. Now this is very directional. So 5G in Canada, very early days. You know, we have 3 networks that have launched in Canada, Bell being one. And so it's super early for that. It's just been a few months under the gun, or off the gun, so to speak. 5G in the USA, they launched earlier than we did in Canada, and that's not because the Americans are more creative or faster or anything of that nature. It's because the spectrum, which I'll talk to in a little bit, the spectrum that's required for 5G was auctioned earlier in the US than in Canada. So they are further down the hype curve. And last but not least, my example, South Korea also auctioned spectrum well over now 2.5 years ago. We are still waiting in Canada for this spectrum to be auctioned. It'll be auctioned mid next year. So it puts South Korea kind of 3 years ahead of us in the hype curve. Excuse me, I'm gonna take some water. So at some point, we'll have these huge heightened expectations of 5G in Canada. I think that will temper down, and eventually we'll have a very, very productive discussion in the marketplace around 5G. Now, the title of this presentation is Beyond Just Speed, and I will talk about speed as one of the 4 chapters, but really to have a true 5G ecosystem, if you will, I believe you need speed, latency, density, and slicing. And I'll talk about each of these in order. I should ask Ian, are there any questions in the chat room at this point?
Just some reminiscing about party lines.
Yeah, good old party lines. Definitely Google that one. So what are each of these? So speed is simply how long it takes to download or upload a large amount of data. You'll hear megabits per second, gigabits per second. These are all measures of speed as it relates to a telecom network. And that's what people tend to get hung up on. Okay, my network's faster than your network. They do a speed test or something like that. And that's speed. But there's really only so much speed that any given application does. What people really mix up between speed and latency, and I do have a chapter on latency to help better explain that, but it's how quickly a network reacts or responds to requests. One of the best ways to think about it is that you can snap a finger. How quickly does that finger snap actually take? That's about 1 millisecond to 2 milliseconds. Has nothing to do with speed. It's all about how quick something responds. And that's just one example of very low latency. Density is the ability to connect to a large number of devices in any given area. Think about that as coverage. And there's really 2 types of coverage. I'll talk a little bit about that. There's the breadth of coverage. How much of the population are you covering? Right, in our case, I mentioned 99% of the population with LTE. And then there's the depth of the coverage. So are you covering every sort of little nook and cranny, every elevator shaft in a large building, those kinds of things. And that's where density really plays a role. And last but not least is slicing. And slicing is where some of the cool stuff that you read about 5G really comes into play. And you need all 3 components to get true slicing, and I'll talk that through. But it's really a combination of speed, latency, and density to offer differentiated services. And I'll leave it at that because there's some cool examples I have later on in the presentation. So speed. How fast will my TikTok load? And TikTok, I chose TikTok specifically because it's a fascinating case study, right? These are really short segment videos, of course. TikTok is number 3 in the world in global video traffic share. So it's right after YouTube is by far the leader, then Netflix, and then TikTok. And when you think about TikTok, the brand name, it had evolution elsewhere, but the TikTok brand name has only been around for 4 years. And yet it's already number 3 in the world. It just shows how fast things are evolving. It's pretty incredible. And so how fast speed, it's actually really complicated. I've tried to distill it down to 4 key components here. And again, I hope I don't lose people, but there's really 4. There's many other components, but I distilled it down to 4. There's the radio. And you can think of the radio as really the cell tower or the cell site itself. And within that, there's various technologies that help that radio work, whether it's the amount of spectrum or bandwidth that's pushed at whether it's the technology behind it, something called carrier aggregation. There's many more, and I'll talk about each of those. Going to the top right corner, a new core. We have a core network. Our core network is, you can think about it as the brains. So of the network, you have all these cell sites attached to the brains of the network, and there's multiple brains of the network, but a new core is required in a 5G world. And that new core and the radio network, those two components at the top, are connected through the transport network. In Bell's case, we use fiber, a lot of fiber. For those that know, we have a big push on building as much fiber to homes directly and as well to cell sites directly as possible. So, and I'll talk a little bit about that connection. And last, but certainly not least, there's a lot of industry influences to get speed. And the industry is really two or three components. There's the vendor community, there's the spectrum availability that the governments would auction off or give away depending on any given country and how they want to deal with that, as well as various standards bodies, chipsets, whether it's Intel or Qualcomm and big chip manufacturers and things like that. And then of course the device manufacturers, the Samsungs, Apples, LGs, and so on. All of that makes up an ecosystem that works with those first three components that I talked about. And I'll take each in order. On the radio side of things, and you'll see this chart a few times because it's a very important chart. And so I'll come back to it a couple different ways. If you look to the bottom of the chart, these low bands, this is sub 1 gigahertz spectrum. This is what we would have built our 1G and our 2G networks on back in the early days. And we are over time, as the technology evolves and things like that, we're evolving that to 4G and 5G. And that's the way you sort of read that. The mid bands, same thing, also started in 2G all the way, will slowly become 5G. The higher bands, technology wasn't there, the spectrum wasn't available, and for a variety of reasons, those all started with 4G and will eventually end up with 5G. And the ultra high bands will be 5G only. And so eventually all bands will be this dark blue 5G. And as you go from bottom to top, you can see the speed increases. And the reason the speed increases is you can see in those gray bars, there's more bandwidth that we can add to that. So the more bits you can push down the pipe. And I'll talk a little bit about that. So this chart tries to frame that up from a spectrum and bandwidth perspective. Really, really complicated. You know, people get full PhDs in just one little element or aspect of this chart. So I don't expect people to learn it right away, but this is sort of a high level way we think about speed. Lower speed in the low bands, much faster speed in the high bands because there's more bandwidth available. Another way we talk about this is you can think of bandwidth as really a road, and the wider the band you have, the more roads you can have. So much like a highway. So if you're down the 400 series of highways, you can certainly go faster, right back to that speed. It also adds more capacity. You can have more cars going down any given wider road. So if you can see it sort of blurred out in the background. I'll go back a slide to show it. Again, the ultra high bands, you can get more roads at the top of the chart, hence the broader speed in that dark blue to the right side. And hopefully that makes sense. More country roads, single lane highways at the bottom in the low bands. There's one other aspect that needs to be sort of mentioned as it relates to 5G. So I'll take you back on 4G. So on the left side of this chart, each of these roads actually had a maximum width. That maximum width was 20 megahertz in 4G. And so when we think about from an engineering perspective, it's all about how many bits per megahertz you can shove down a road. They were only able to maximize at 20 megahertz. Eventually, as 4G evolved, I'm now on the bottom left of this chart, we could add multiple channels. So it's almost like we were stacking more roads together so more traffic could fit and therefore more speed. Hopefully that makes sense. So it's really 4 times 20 for a total of 80. On the far right side, top right, in a 5G world, you end up, if you think back to that previous slide on spectrum where I said 5G is only in that ultra high band, big wide channels, the channel size in 5G is 100 megahertz. And what that means is you can fit a lot more bits, a lot more capacity, therefore a lot more speed. The only caveat to that is if that spectrum is good and clear in that 100 megahertz, great, you have full use of that 100 megahertz. If for whatever reason, another company or user or carrier or whatever the case may be is actually within that spectrum because they've been licensed to provide there, or it's a satellite system or whatever the case may be around the world, then you're actually limited, and it'll actually block some of that speed from truly coming through. And so you won't be able to maximize. So all the channels, the more contiguous the channels are, the more throughput you kind of get. Back to the road analogy, kind of makes sense, right? If you've got a whole multi-lane highway, you're all run down, you can run down all 6 or 8 lanes all at once. If you've got construction down the middle, everything's going to slow down. Same exact idea. So to kind of make this more practical for a user, customer perspective, in a 4G world on the left, you have the 4 times the 20 megahertz. You're actually coordinating all those channels together. You get 80 megahertz maximum kind of throughput. And of course, as you add multiple lanes, just like you would, or multiple roads together, you actually have to get between those roads and things like that. So things aren't as efficient in a 4x20 as they are in a 2x100 megahertz. As one example, you could see the speed dramatically increase from 4G to 5G. Another thing that affects speed of a network is that transport network that I talked about earlier. This is what connects, if you look on the left side of this picture, this is what connects the central office, or the brains of the network, to the cell site. And at Bell, we use fiber. It's a direct connection. It's the fastest connection. It works at the speed of light, of course, because there's lasers at either end. It's also weatherproof. It's not susceptible to rain fade or things of that nature. So a lot better. The other thing it's better for, and I'll come back to this slide in my next chapter, 1 millisecond latency, very, very fast. And so that's also important to remember. And I'm going to pause there and just ask Ian if there's any questions in the chat room.
Yeah, so we've got Mark Bornay who's asked about reports that they had some issues getting sufficient coverage inside some Government Canada buildings in Ottawa, and wondering about, with 5G being still prone to being blocked by building materials, how can they ensure adequate coverage without having to, I think what he suggests is invest millions in repeaters?
Yeah, so a couple things. One, you can always call us and we can look at that building specifically. And you can reach out to me. People can find me on the internet and send a question directly, and I'll maybe offer that to anybody who has a similar question. Yes, 5G, just like the other generations of technology, are all susceptible to the physics at the end of the day. So if you are in, I'll do an extreme case. If you're in a Faraday cage, which is much like an elevator shaft, all metal all around, unless you have a dedicated small cell site in that elevator shaft itself, then coverage would be very, very limited, if not non-existent. And that's just the pure physics of getting signal into areas that are metal. Concrete is another challenge, because typically concrete, especially in commercial buildings, has a lot of rebar in it, back to that metal, and a real challenge. So not unlike your microwave or something at home, just can't get signal through. And so these are things I'll talk a little bit about that when I get to the density section, and how we are working to improve the density. I talked about the breadth of the network, and that's kind of macro coverage across the country. The depth of the coverage is just as important, and depth being right into those in buildings and things like that. So hopefully that helps answer, but there are techniques. 5G is a little better at managing interference and penetrating than 4G, just because algorithms improve over time, but there's still those basic laws of physics that we can't break, of course.
Understood. We had one other question from my friend Steve Woodward on what is the reality of reported health concerns that I guess some folks hear about. And I'm going to assume that Stephen is not talking about how 5G infects people with COVID-19.
Yeah, well, there's that too. You know, there was, I think that started in England with Vodafone or something like that, and sort of swept actually the world with conspiracy theories around 5G and the coronavirus, which is complete conspiracy theory. You know, we of course follow, we and all of the wireless carriers are mandated to follow World Health Organization and Industry Canada as far as you know, safety guidelines and things like that. So 5G is no different than 4G, 3G, and 2G. It just happens to be a different, newer technology, but the same basic physics principles all hold true. And we ensure, as an example, in the industry, that engineers are stamping and qualifying any of the equipment that goes out into people's hands and homes and things like that. It's a big industry, so we manage that very, very strictly according to all the rules and regulations and World Health Organization guidelines. So
cool, thanks, Stephen.
Latency, and I call this also known as quickness. And this is one of the big differentiators between 5G and 4G. And I'll try to make that as clear as possible. So I'm going to start by defining latency. And I'm actually going to read this out because I think it's very important. And this is from a telecom perspective, because there's latency from other perspectives. But it's how quickly content or an application responds to a user request, how much time it takes for a signal to go from A to B and back to A again. We call that the round trip time latency. So everything I talk about is from A to B to A again, and very important. And so connecting to the internet for some applications, we don't need to worry about latency. For others, very, very important. And I'll get to that this next slide. Why does it matter? And latencies, if those that are Michael Lewis fans of his books, he's got this one called Flash Boys, I believe. And I was looking for it the other day on my bookshelf here, but I couldn't find it. It's a great book, but he spends the first chapter or two actually talking about latency and telecom networks. Because for the banking industry, traders, you think of traders, both physical traders as well, and now all the automated traders, really deal in milliseconds, and milliseconds can mean millions. And if you look to that right chart here, if someone were to say, okay, sell now, but they actually don't sell for a couple milliseconds later, then the actual sale price can go down, which is bad news. And so you want it instantly from the time you say sell to the time that's actually sold. That needs to be instant. Same with autonomous vehicles, right? If the autonomous vehicle is saying stop, but it doesn't react fast enough, then that poor bunny could maybe not move fast enough to get out of the way. And so really important as it relates to fully autonomous vehicles. And there's a whole bunch of other applications. There's thousands of them that actually examples. I've just got a couple here where there's drone control or some autonomous mining, augmented reality and virtual reality. For those that tried early virtual reality headsets, if you may have had that and you felt that sort of dizziness or motion sickness, that is actually latency. And if it's high latency, you may not notice it to your eye that it's highly latent, but your brain and the eye need to be connected. And if what you're watching is slightly different than what your brain is registering, then you can get that motion sickness kind of queasy feeling when you've got the virtual reality goggles. So the lower latency, the better in that kind of example. And I already talked about the high frequency trading and how important it is for bankers in particular. There's a few other use cases. There's many, just like speed, there's many factors that impact latency in a network. And I'm going to talk about just 3 of them. and highlight 3 of them. I have a high-level diagram of a network and what it could look like. The 5G radio, this is the cell sites. You can see it whether it's hooked up to a rural rural home, or to a person, or to a machine. It's all kind of the same as it relates to the technology itself. Transport, again, that's fiber between our cell sites and a central office. And then something that'll called multi-access edge compute, which sounds like a mouthful, or MEC for short. And I'll describe that a little bit later. But all that is intended to get, how do you get into that broader internet? How do you get to that broader internet? And again, you want the shortest distance, right, to have the lowest latency. On the radio side, this chart now will hopefully look familiar. Changed slightly. So the speed, not talking about speed here, but you see the speed increases over time, right? Really low at the bottom, high speed at the top. It's the exact opposite with latency, and which sounds a little counterintuitive. You know, why is it the exact opposite with latency? Think about these ultra high band and this big channel I talked about, right? You can stuff a lot more bits into that big channel. And by stuffing a lot more bits in that big channel, you get more speed, yes, but there's also more bits that you can use for that speed and fewer bits needed to coordinate things across a whole channel. So the percentage of bits that you actually are using to coordinate things, whether it's a handoff to another cell site, whether it's sending details on a game, or your profile, or whatever the case may be, you're actually using fewer bits, so or more bits for that, and fewer bits as a ratio of the overhead, and therefore you have lower latency. A little confusing, a little more difficult to grasp than speed, and so let me take it to the bottom, and I'll then use a lower or a higher latency example, lower speed. So you think about that small little narrow pipe in the low bands that we're talking about, right? You can only fit a certain amount of data. In order to have handoffs as you're driving from one cell site to the other across Toronto, let's say, you need a whole bunch of those bits to do multiple handoffs and things like that from one cell site to coordinate all that activity and everything else. It's a lot of volume of data that's not really going to the data itself, the video or whatever else you're watching. And that high volume of data takes away a whole bunch of things, which means you are actually now using too much as a ratio of your data, and therefore you're not getting the low latency that you would require. And I hope that makes sense. It's a lot of talk, a little confusing, but if you just think of that trade-off between those two, that's really the best way to think about wider channels, lower latency. And low latency, a small number, is a good thing here, and I'll show that in a few minutes. On the transport side, same slide I had before. In this case, I'll take you to that second row. It's a laser. It's at the speed of light, almost at the speed of light. I'll put in air quotes. And so very, very low latency. And in this case, it's all about distance. The distance from the cell site to that compute at the central office. The lower you make that distance, therefore the more cell sites you have, the lower latency you have. Very, very important. Latency is really all about geography. And if you can think about it in simple terms, if you're yelling at someone across the way from you in the park, or you're yelling really, really close by or talking really close by, they hear it immediately when you're talking close by. They don't hear it immediately when you're further away. Exact same concept. It just happens to be the speed of light that we're talking about as it relates to fiber. Now this MEC, or multi-access edge compute. This is pre-MEC. So this is the current way networks are designed. So in Bell's case, we have fiber to a cell site. It goes to a central office. It probably goes to a couple local data centers, and then to the what we call our global data center, and then out to the internet. Again, add on all those distances. This is a distance game. Latency is a distance game. And so we compute this depending on how many central offices and other nodes are in the way, anywhere from 3 to 35 milliseconds. If you were to do a speed test right now on your device, you would hit in that range, 20, 28, 30, depending on how close you are to a cell site, depending on how close that cell site is to our data center and so on. That is what you are seeing from a latency perspective. And people don't notice, honestly, to get echo on a phone conversation, you have to be north of 100 milliseconds, right? Snap your fingers. You're not going to notice that kind of difference in 3 to 35 milliseconds when you're on a phone call. But there's a lot of applications, autonomous vehicles, automated trading, that really require low latency. And so that's where MEC really plays a role. And so in the MEC world, you can see all I really did was shrink this slide. I moved that compute, that brains, if you will, that edge of the network closer to the internet. And it's simple as that. So you removed all that 0 milliseconds of latency, that 30 milliseconds, I've now chopped all that out. And you now only have just the latency between the cell site and that edge data center. Again, it's all about geography. Sounds simple, and that's maybe a simple way to put it. It's all about geography. There's other complicated things behind it, but that's as simply as it can be put. So with that, I'm going to ask if there, maybe pause if there's any questions on latency. It's a really important thing because it's one of the big differentiators to understand about 5G.
Yeah, Stephen, thank you. So there is a question from Walter on what impact you see in terms of 5G being allowing the adoption of IoT in public infrastructure. And I suspect that kind of connects with what you were just talking about somehow.
Yes, it does. It does. And I'll actually talk about that a little later on as well. Thanks, Ian and Walter, for the question. So I'll make sure I insert a bit more IoT later on. But there are a lot of applications IoT related that don't require latency. And I'm thinking about, I don't know, monitoring, monitoring a home network, your Nest device at home or something like that. It doesn't need to be within milliseconds, as long as you're changing the temperature within the next, remotely, as long as they're changing the temperature or something like that within 10 seconds, a minute, whatever the case may be, latency doesn't really affect it. Where it will be very important latency is with an IoT mining application, or if you're monitoring a wellhead or something like that, where millions of dollars can change in a matter of seconds, and it's really important to shut something down if there's a leak, as an example. Those kinds of things, the lower latency, the better. And I'll talk about a few of those examples later on.
Awesome.
Density of network, the third concept. Again, coming back to this same slide, and I'll repeat the low bands, low speed generally in the low bands, high speed in the high bands, the exact opposite with latency, very low latency in the high bands, a higher latency in the low bands. Similar kind of thing with distance. So high bands don't go as far, and low bands go very, very far. And you can think of this as it really relates to a couple analogies I often use. One is if you have someone with a very low voice, like me, you will hear my voice a lot further away than you will someone with a high voice. Or high-pitched music you don't hear, but that subwoofer or the boom, 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 you hear much, much further distances. Same kind of idea. Low band goes further, high band not as far. Dropping a big rock in the middle of a pond, you get a big wave, and that wave goes a lot longer than if you drop a little pebble and just ripples across and decays over time. Similar kind of concept. Okay, so That's the way to think about spectrum reach. And very important as it relates to density and coverage. What we would typically use for coverage, to cover that 99% of the population, we would use lower bands as our base band, and then grow mid band and high band as it relates to dense urban areas. And how does that play out? So on the left side of your screen, before network densification, you can see this woman in the middle. She has access to the low band, low and mid band, this lighter blue color. And so she's getting decent speed, but higher latency than the person on the right, because they're in the ultra high band kind of coverage. And so they're much, much happier with their faster speeds and so on. And so on the right side, as we add more cell sites into our network, and we are constantly, all carriers are constantly adding cell sites to their network, you can see that by inserting that cell site, you can take advantage of all of your spectrum assets. So you always get the low and the mid band because they can reach a little farther, but now you're also getting the ultra and the high band access, and therefore the higher speeds and the lower latency. And that's something we're constantly trying to do. So back to that question about in-building, as we add more cell sites, the in-building penetration also gets better over time, just naturally as the network grows over time. And where does this really play out from a customer perspective? In large events. This is my plug for the Raptors. Go Raptors. This is their parade. You can see 2 million people or whatever it was in downtown Toronto that day. Bottom left is the Boots and Hearts Festival. Really important to not only get coverage, but that density of coverage, just because the number of users is so dramatic. And that'll get even bigger as everything moves to whether it's connected smart cities or industrial IoT sensors. And back to that IoT question, just the density of devices. If you're going to have every single stoplight, as an example, have an IoT, wireless IoT sensor on it, that's a lot of density of devices. And 5G can handle those kinds of densities. And that's why it's important for us to continue to densify our network. Any questions there, Ian, or I'll just move to slicing?
Looks like we're good to go.
Great. On slicing, this is the really cool stuff, frankly speaking, that you read a lot about. And really all slicing is it's getting just a slice of a network from end to end. So right from that customer, whether it's a fire truck or a drone or a person on the phone, or even a bank hooked up to fiber, getting a slice dedicated to them across the network right to that application, whether it's a banking system or voice or whatever the case may be. And that's what a slice is. So you can think of a slice as a dedicated virtual kind of circuit. And I'll give you a few examples that will help solidify it. Without slicing, we're really on a best efforts. Everyone gets equal access to network capacity, and that's in the left side of this slide. So whether you're public safety or you're a voice customer or you're doing broadband, you're all sharing that same connection essentially. With slicing on the far right, we can prioritize, right? Should a fire truck have more capacity and lower latency than a voice call? Yes, absolutely. You could always argue that. And so these are kind of the applications that'll end up unfolding, and I'll talk about a bit of the use cases on my next slide. So public safety. And so I'm just going to take a few examples of slices, and these are hypothetical because this world doesn't exist yet, but it will in 5G in a couple years. And so public safety, should they have low latency? Yes. Yeah, you want an instant response, right? And should they have guaranteed bandwidth? Absolutely. You know, you want that fire truck or that ambulance to be able to respond and be able to do the video upstreaming or whatever they're doing on board to make sure that patient is healthy. But social media, probably don't need low latency. Probably getting a TikTok or Snapchat or whatever in a second is probably fine. Certainly not in the sub-millisecond type of range. Best efforts, also similar. You know, they're not going to pay for dedicated bandwidth just to run TikTok or whatever the case, because 911 is absolutely most important. And so that is a slice. This is all coordinated, if you will, through the brains of the network, this intelligent core. that'll be coming soon to all networks. So another example, and this I think is very relevant for today's working from home in COVID-19. You know, how does mom get a much better connection in that same household as her son who may be watching YouTube? Right now there's this wrestle, right? Everyone gets equal access. Well, no, you know, one of these things we can do in a rural broadband context, as an example, again, with our 500,000 locations that we have available for rural broadband, they, in the future, will be able to get a work from home slice. And what that work from home slice, maybe they get a VPN that's got really low latency and they guarantee their bandwidth. So they can do their WebEx call or their Teams call or Zoom call or whatever it is without any shake up and poor video quality or anything like that. And maybe the son does get in slice number 2, he just gets best effort bandwidth. You know, maybe it's fine that the things buffer every once in a while or whatever the case, versus mom who's really trying to work and do some good banking, as an example. So these are the kinds of things that I think we will see in 2, 3, 4 years time, even a work from home kind of environment. Mining, this would be an interesting sort of IoT kind of industrial use case. There's 3 slices I actually have here. Slice number 1, lowest latency, minimal bandwidth. Well, why is that? So blasting, clearly you want really low latency, right? How does it react instantly? But there's actually not much bandwidth. It's either kind of turn it on or turn it off, turn it on, turn it off. There's not a lot of video or anything like that going through in the blasting. So that's slice number 1. Slice number 2, they probably do have a lot of video. You know, if it's an autonomous, I don't know, $1 million bulldozer that you're now working remotely, you want to be able to watch the video and be able to, from headquarters, you want to be able to turn the dial and dig or whatever the case you're doing. And so it needs to be very low latency because it's got to be fine-tuned, but also guaranteed bandwidth, because you want that streaming video to see what you're actually digging away at, so you don't miss any of that gold or diamonds or whatever the case may be. And then management can actually be slower than both of those. Why? Because you're not going to really need to react in the milliseconds. Maybe you react every minute or every 5 minutes when you're getting reporting, or every 10 minutes, or maybe it's an overnight kind of data run that you're doing or whatever the case may be. So there's no latency requirement per se, and maybe it's just best effort bandwidth. So here's an example, one use case of sort of IoT with management on top, where you could actually have 3 different slices working at any given time. So with that, that's really, I've taken you through each of the 4 chapters. You know, I'll talk now in closing. Your speed, people talk about the speed. It's the first benefit to arrive with 5G. You know, we're all advertising different levels of speed, and speed will continue to grow. Just like every other technology, it always gets faster and better, and so on. Latency is really the first substantially improved thing that we will see. There are devices required and services that will take advantage of it. Not all services will take advantage of it, but VR, drones, mining, things of that nature will all take advantage of latency. We talked quite a bit about density, how you need density of network, you need breadth of coverage as well as depth of coverage over time. And last but not least, putting it all together is something called slicing, and it's done with this really smart, intelligent core of the network, can really help manage all these bits and help navigate this world that is getting more and more complicated, even as I speak practically. So with that, I do have quite a bit of time left. I'm happy to take any questions, either if you want to raise your hand in the room, we can open it up for a voice, or if you want to just go to the chat, I'll open that too, and we can take some Q&A. That maybe I'll actually stop sharing my deck too.
Great. So I don't know that this Zoom room has the ability for people to raise their hands. And so we do have a lot of people involved. So there's a couple of questions in the chat I can relay to you, and some
Yes,
more are coming in. So maybe
I'm looking at them right now. I can go, go Raps go. I like that. Post-COVID life 2022. Yes, hard to imagine. I agree. Forgotten what friends and crowds look like. Yes. Is slicing the same idea as split tunneling? Yes, kind of the same idea. In fact, we kind of do slicing in a rudimentary way now on various networks. Quality of service, people would have heard of quality of service and setting certain parameters for quality of service, but it's a very sort of blunt instrument. With slicing, things will get a lot more automated and a lot more precise in the types of, some of those examples that I talked a little bit about. Yeah, algorithms being looked at for slicing. Yes, there is a whole standards bodies dedicated around slicing, and it does require new equipment and new software. So I talked about earlier about this new core and how that will evolve over time. And slicing, even slicing itself, there's sort of this concept of manual slicing that's sort of, call it 18, 24 months away, and that'll evolve into much more automated kind of slicing in 36, 48 months. So just like every other technology, it'll evolve over time. How do I think 5G will impact society? That is like the penultimate question. If I knew the answer to that, I'd probably be an investment banker. Because, when you look back to the 4G, and I've been personally involved in really 2G networks, 3G, 4G, and all the various combinations thereof throughout my entire career. And if I could have predicted the end result, I should have been an investment banker, but I'm not. All I know is that things will change dramatically. Who would have predicted that TikTok would be #3 in the world 4 years ago? People would say, really? I mean, that's kind of a silly thing, and it's just massive now. So there's going to be, I will say this, I truly believe that there'll be much more positive than negative, but you will hear about the negative, because we always do. Oh, if we didn't have this, we wouldn't have had that issue, whatever. And that bad people are taking advantage of technology, and they do. But there will be a lot of good coming from 5G, just like there was in all the other generations. Will rural benefit from this also? Yes, absolutely. Rural will benefit, and we are doing that right now. And so that wireless home internet that I talked about, that is 4G, we will and are working on 5G as it relates to that. So rural Canadians will not be left behind from that perspective. It is more expensive, of course, to deploy in rural than it is in urban areas. And so that's always a constant challenge. But yes, our plan, much like we have 4G to 99% of the population of Canada, we will have 5G over time, not instantly, but also to 99% of the population.
Hey, Stephen, I know there's a question a little bit further down that might relate to that, which is about Starlink and I guess satellite as a delivery model. Does that play into the rural coverage scene? And yeah, I guess just what are your thoughts on where that fits in?
Yes and no. Let me genericize it, not from Starlink specifically, but more low Earth orbit satellites. And there's a bit of a crossover in those technologies. We do use satellite technology in rural areas right now. We did, I think, a wonderful program that took us about 2 years to build. We launched it a year and a half ago-ish. We called it Tamarmak Noon Elite, and which means every community in, and what it was it was 25 communities up in Nunavut, and how we connected those communities to 4G technology. And it was a combination of us, the Nunavut government, the federal government, and Telesat, another good Canadian company, who connected those rural, very, very remote communities to the internet and to wireless. And we used satellite as a backhaul, if you will. So where I showed that fiber connection between the cell site and our core network, we can't get fiber up to the northern tip of Baffin Island as an example, but we can get satellite there. And so that's what we did for those remote rural communities. And so we'll continue to experiment with those kinds of things as it relates to LEO, low Earth orbit satellite technologies. And those will eventually all be 5G. So those 4G, just like every transformation of technology or evolution of technology, will become 5G over time.
So thanks. We got a question from James on whether 5G can actually start to replace sort of the maybe the last, I don't know if you'd call it the last, maybe not last mile, last whatever distance is to the home.
Yes, well, we are already doing that. So the answer is really urban versus rural. So 5G, 4G right now, 4G we do deliver to nearly 500,000 locations, as I mentioned earlier. A 4G technology to do that sort of last mile. Depending on how far people are from the cell site, it's actually 5 to 10 kilometers away from their cell site. The challenge is that spectrum is a shared spectrum, and it gets a little complicated physically, but we aren't able to offer the dedicated speeds that we are in urban areas where we're building fiber, because the fiber goes directly from really that nearest telephone pole into your home. And so that's the difference, and it's just so expensive to do that in rural areas. I mean, it's expensive enough to do in urban areas, but very, very so cost prohibitive. The payoff would be hundreds of years in some rural areas. And so something that's unaffordable, but where we can, we do wireless for that quote unquote last mile.
Cool. Well, while you're grabbing a drink there, Randy's got a question that's near and dear to my heart, as I work in the software defined area of communications. And his question is, or her question, sorry, Randy, will the bandwidth be configured via front-end app, and will you be able to adjust on demand so that someone can go and just dial up more bandwidth for their VPN?
Yeah, Randy, that's a great question, and that's a TBD. My vision would be yes, in concept. You know, this is again early days in 5G, and I think there'll be sort of a consumer version and a business version. So the business, let's say it's an enterprise, yes, they would have a portal and they would be able to configure, I don't know, bank branches, let's say, and the bank branch for during, I don't know, RSP and tax season or something like that needs to have more bandwidth and lower latency. And so maybe they pop it up for those 2 weeks and spend a little extra money to make sure they have the guaranteed bandwidth and low latency or something like that. And maybe during the summer hours, maybe they just go to a normal thing and you just configure that right on a portal. And I do see things like that, sort of those concepts emerging. From a consumer perspective, it gets a little more complicated because we need to really simplify it much more, a la Apple or Android has done to really simplify things. And I could envision, you know, is there a gaming and you click, okay, I want the gaming app, and you may not know what that means other than your gaming experience is better. And do I have the home office app, and you click on that, and then your video is automatically guaranteed. So we need to, because there's no CIO in the consumer sense that the business would have, their consumers, we need to really simplify it for them. And maybe it's just a series of apps or clicks that we say, oh, you want the gaming one? Well, that's, I don't know, $70 a month. You want the super duper home office one? That's $80 a month, and you click, or something that, you know, will be something TBD, but you could see that that's how my gut would say things will unfold, but we'll see.
Interesting. Yeah, it seems like there's so much opportunity there for innovation. So we've got Yuning, who has asked about, you know, you mentioned the spectrum auction is happening in half a year, and yet 5G is already in the process of being rolled out. and that's confusing. Is one dependent on the other? Can you give us an idea of what's going on?
Yes, it is confusing, and I apologize for that. I try to simplify, and you caught one of my trip ups right there. And so it is a little confusing, but let me say, if you think back to the chart where I had 2G to 3G to 4G to 5G, and so 5G can work in any spectrum type. And so if there's an area of spectrum where we have for 3G or 4G that we're not fully using, we can actually insert 5G into that slice of spectrum, into that roadway, if you will. And that's how we as a collective have been able to offer this kind of earlier version of 5G. What I would call true 5G really happens when this 3.5 gigahertz auction happens. And that's all public knowledge. That is called mid next year when the auction will start. And so that is something what I would call really true 5G in air quotes versus sort of these earlier 5G that are just kind of taking advantage of the 4G spectrum, if that makes sense.
Yeah, I think it does, and yeah, it is. It can be a little confusing if you don't know kind of all the things that are required to support the rollout of these services. We have an interesting question, speaking of which, about what comes next. I mean, obviously, we're just in the early days of rolling out and being able to use 5G. I guess Apple the other day kind of put 5G on the main stage in the consumer world by launching their new iPhone. But I think most of us still haven't experienced it yet. But Dennis's question is what's beyond 5G? How long is this generation going to be? And then do you have any ideas as to what's next?
I do have ideas of what's next. It's called 6G, I'm surprised. And there'll actually be various iterations of 5G sort of along the way, but there are concepts being thrown around 6G. People are talking about tactile internet and things like that. What tactile internet is you can actually sort of feel, if you wanted to do, I don't know, remote surgery or something like that, you could really do it in a tactile kind of internet way. We'll see. 10 years, I don't know. If you look back to or think back to my generation slide, they were each all about 10 years separated from each other. Things are getting a little faster, so maybe it's 8 years, but it'll come. Technology does evolve. I see one question about the wooden thing behind me, and you must have missed the introduction, but I'm going to go back to that one because it's one of my favorite things for those that missed it. This is a picture frame. It's called a picture frame wall phone. It is from the 1920s-ish, from my grandmother's farm, and it's it is just in my home office. It's not something I stuck up just for this presentation, but I've been a telecom guy through and through for a long time, so that's why it's there.
That is a cool piece of hardware.
Yeah, I love
thanks for
it.
sharing it with us. And one of the better background objects in this pandemic. It seems a lot of folks have interesting things in the background. I think that's a pretty cool one. I'm seeing we're kind of at we still have time for questions. We've got about 20 minutes. And since we've gone through the list so far, I encourage folks to please add more questions. I actually have a question, and it's about sort of the role of Canadian owned and operated infrastructure in sort of a digital world. And so a couple of the things we've been seeing in recent years is controversy around, speaking of equipment, whose equipment are we allowed to use in our networks, right? Has come up recently as an item of controversy, and different countries are taking different positions on this. And I mean, obviously, to do digital at the end of the day, yeah, there's the cloud, but at the end of the day, all this stuff is fundamentally founded on real physical objects and physics. And I was wondering if you could give us an understanding of not only the importance of controlling, like how important is it for Canada that we have Canadian companies that control telecommunications infrastructure, and where do you see that going with the the tensions around I guess, not just data sovereignty, but let's just say the sort of sovereignty of infrastructure and domestic capabilities?
Yeah, that's a loaded question. So I'll break it up if I may. So a couple things. You know, we always comply first and foremost with any government kind of mandates, and we do respect all the laws and data privacy and everything in everything we do. And we do believe in delivering the most. When we talk about best network, we actually define it as the largest, the fastest, the best quality, the most secure network. And so we take it very, very to heart, these kinds of things. And so, you know, as an example, our 5G network is it's early days, of course, but and we've made this public a number of months ago. But the two principal vendors are Nokia and Ericsson, are our two principal vendors. But that's just the electronics, which is actually a relatively small portion of what we do. We use all local Canadian where we can, and if available. So if there were a Nortel, and may they rest in peace, because I was a big fan of what they did. If there were a Nortel, then you know, we would certainly look to use them, but there isn't. That said, Ericsson does have a lot of Nortel in its legacy because they bought some of the assets, and Nokia has a big, they both have big R&D and local presence in Canada, so they're investing in Canadian jobs. But a lot of the infrastructure, so when you think about those cell sites, the towers, the construction that goes into that, the digging for the fiber and everything like that, that is all Canadian jobs, and something we're very proud of. You know, we spend $4 billion a year in growing and maintaining our networks, and when you think about the proportion of that that rests on Canadian soil and helps Canadian jobs directly, is by far the vast majority stays on Canadian soil. And then there's the indirect, of course, the job creation because of delivering these networks that we're also quite proud of too. So, and data sovereignty, you know, I think is a really important issue, and something that our customers should find very important as well. And so our business customers, I know, take it quite seriously. They want to make sure that you know, the data centers are located in Canada, which they are, and consumers are becoming more wary or educated around it as well. So
Who's that? Who's that?
Oh,
Okay.
we have an EF who's gone mic
should go on
live.
mute, yeah.
Yeah.
Maybe Dennis can help us mute that.
Yes. Oh, perfect.
Thank you.
The wonders of modern technology.
It is quite amazing. Thank you for handling my my very complex question with such poise. We do have another question here that's sort of going way back down into the details from a super high level. Walter's asking how you would compare 5G and LoRaWAN in IoT applications. Do you expect 5G to eventually replace LoRaWAN?
I do. You know, that'd be my my humble opinion.
Maybe we can, sorry, Stephen, maybe for those of us who don't know what LoRaWAN is.
Yeah, so it's I'll call it an early IoT technology that so if you think from the cell site to the device, that is just different than 5G, a very similar kind of concept. What they got off out of the gate much faster than the telco world did. Did some great invention, I would say, and got into the IoT space. I'm not sure how many years ago, but several years ago, and have done a good job kind of building up. I believe the broader worldwide, I'm now taking this worldwide, the 3G, 4G ecosystem is now billions of devices. I mean, billions, right? You think of 8 billion people in the world, and whatever, 6.5 billion of them have a 4G device or some big number like that. I don't know. Don't quote me on that one, but it's big. That ecosystem just marches on. And so if you think about the ecosystem and driving an ecosystem, and that's the cost of handsets, the cost of chipsets, the ultimate cost to consumers and things like that, from a big ecosystem will continue to drive. And so there may be a place for low RAN, but I think over time 5G will overtake it and be far bigger.
Cool, thank you. So we've got another question from Steve Woodward, and I think we're switching gears yet again. So
yeah,
hopefully you're on your toes. So his question is, how concerned are the telcos with the cloud service providers getting into connectivity? Steve acknowledges the challenge of telcos having trouble competing versus hyperscale service providers. So will the cloud providers now compete with the carriers? Where do you see that going?
Yeah, that's a very interesting question. I think it'll ebb and flow. Certainly the cloud, Google, Amazon, Azure, those are sort of the big three. You know, don't count any of those three out. They're just big Goliaths, you know, and we are David. And I think that sometimes gets lost in Canada. People would think, oh, Bell, you know, you're so big, and we are not big at all. And this is a capital intensive industry and something that really requires a lot of scale, and those three just have massive scale. And so could they compete? Yes. Will they compete directly? That's interesting. You know, Google Fiber tried, and they were building fiber in Kansas City and a few other municipalities, and have largely slowed that down in the US. They're all playing in some form or fashion with LEO, these low Earth orbit satellites. And so we'll see. I think in the Venn diagram of overlap, there is some overlap with telco directly, of course, but there's also a lot of open space where they compete and we compete. And so we'll see. I think that Venn diagram of overlap will ebb and flow over time, depending on really depending on them. They're just big and you know, want to grow. So we'll see. But we are small in the ecosystem of things as it relates to not only telcos, but in the broader internet space. We are very small, and this game requires scale.
Super interesting, and I think it for me, part of your answer ties to this question of being more on the software side of things. Sometimes we lose sight that there are real physical infrastructures and people behind these services. And Google's the example of Google Fiber in Kansas is an interesting one, because it's very hard to software define all the different ins and outs of rights of way and agreements from one municipality to another across a whole country. And so we'll watch this very closely, obviously. Great question, Steve. And thank you, Stephen, for the answer on that. So we have Rani again, who's got another question, which probably interests everybody, on the price comparison for 4G versus 5G. I mean, we're getting all these new capabilities, better performance, lower latency. How is that going to affect the cost of services to customers?
You know, this is where I pull my engineering card. I'm the engineer. I build it and operate it. I don't price it. I will say this, you know, we, as an industry, and we at Bell, we invest $4 billion a year, like I mentioned, and just even keeping up with basic demand on our network is incredible. You know, the network grows at 50% a year every year, and so that does come at a cost. So I'll let the marketing product people price that, but just to say it, certainly, you know, the internet isn't free. It does cost to build and operate it.
I guess maybe a twist on that, and sort of Dennis, you know, chimed in here, is the cost of implementation going up from what you can see? Because maybe you're not on the the sort of the revenue side, but you probably have a good understanding of the cost side. What are the trend lines there?
The costs are going up. It is getting more challenging and more difficult. You know, the software that I talked about, just to go into slicing as an example, is very complicated. And it's not like connecting a voice call back in the old days, or the party line in the really, really old days. And so those costs are going up. I mean, you think about latency and trying to get that sub-millisecond latency and putting all that fiber in the network. That's a lot of fiber, which is a lot of digging and trenching and very manual work. And so the costs are unfortunately going up.
Is there, so we have another question from, in this case, from Daryl, that might, relate to this. One of the ways I think of defraying costs of infrastructure in a software-defined world is multi-tenancy. And so slicing is something which seems to support, better multi-tenancy. Is there a limit to the degree to which you can slice and dice the network, for, I guess, at a certain point, Daryl points out, for public safety, you probably need to have some kind of minimum guaranteed service levels for certain tenants of this network.
Yes, there is a practical limit to how much you can slice and dice. There's really no, there would be a theoretical limit as well, but there's a practical limit. And I mentioned that a little bit in the consumer world. There's probably a gaming kind of version, a home office version, maybe alarming in your office version or something like that. 3 or 4 slices that you may want to envision, just to keep it really simple for consumers, so they can point and click and be done with it. And so you wouldn't want to give them 10 different flavors of home office, because they're not going to be able to figure out what they want. So there's that practical. In the CIO, more enterprise space, can be more complicated for sure, but there's still also probably a practical limit. If someone that's setting up a bank branch, they may only want 3 choices or 5 choices or something like that. So we might have a retail, 3 choices, a banking, 5 choices, something else. And so there's going to be these practical limits, including public safety. And so it'll all be software defined. It'll all be multi-tenant. So we do now run our data centers are multi-tenant internal, not multi-external Bell, but internal Bell workloads are managed. So we would have our Crave app running right beside our 5TV app, all in the same infrastructure as a service, as an example. So we do already are very much like the cloud providers that way already.
Interesting. I've got a comment from Dennis that hoping that there will be an impact on data caps. Where do you, obviously data caps is an example of something that presumably was done because capacity is limited and costs are high. You don't do them just for fun. So where is that heading? Given that one would imagine that if you increase the data caps substantially, you actually open up new use cases industrially, not just consumer side, but also industrial side, because today those wouldn't be cost effective. So where's that going, if you don't mind?
Yeah, so we'll be market competitive. I think that the market will set rates, as it always does, and does a great job in setting market rates. So that's maybe too motherhood and apple pie kind of statement, but I think it's true. So as I said, the costs are going up. So it's how we manage, to take the other extreme case that, the internet isn't free. We spend hundreds of millions of dollars just keeping up with capacity, that 50% growth I mentioned. And so, it's tough.
Sounds
TBD.
Tough business. Sounds to be determined. But obviously, I think everybody's voting for more bandwidth. It seems like the demand.
Yes, people always want more bandwidth.
You must have your own data on how much increase of demand there has been for data in this pandemic, and
yes.
hopefully 5G will be able to support that increased demand and then some.
Yes.
So thank you very much. I want to wrap up now, as we do technically have until 4:30, but I think Alistair's closing remarks start now. So first of all, on behalf of everyone, Stephen, on behalf of the conference and all the attendees of the session, thank you so much for a really interesting walkthrough. And I know you mentioned that it's a struggle to sometimes make it accessible, but I thought you really had a nice level of accessibility to a complex topic.
Oh, thank you.
So
thank you very much,
Stephen.
I appreciate it.
And thank you to the attendees who had really great questions.
Yeah,
that made
very
it
good
really
questions.
easy.
I really appreciate it. Yes, agreed.
Easy for me to do my job, and obviously also easy to get lots of additional insight from Stephen. So that was really fun. It was greatly appreciated. I just want to highlight quickly for those who are still on that at 4:30 we've got a few topic rooms. There's one topic room for designing COVID alert. So that'll be tied to obviously exposure notification if you're interested in that application with the Canadian Digital Service, the CDS. We've got another topic room on improving the digital work and strengthening the digital workforce of the future, which should be really fascinating as well. That's something which clearly we all realize why that's important now. And finally, there's a topic room on digital learning exchange. So about democratizing learning and why it's so important that we all participate in that. And so on that note, there's still some interesting sessions in those topic rooms, and you can catch Alistair's closing comments if you so choose. And Stephen can be reached, I think, as he mentioned. Actually, I'll let you say it. Stephen, how do we reach you if we want to connect with you?
Yeah, you can just Google me. People seem to be able to reach me by a whole bunch of different means. So just Google me and I pop up. Thanks so much.
That's great. And I think through the platform as well, there's ways to signal your interest in connecting with Stephen. So thank you, Stephen. Thank you, everyone.
Thanks, Ian. Appreciate it. Have a great day. Be safe.
Take care. Bye now.